In this video, I'm going to show you how to build your own vehicle-mounted solar-powered Meshtastic node step by step. You can find the complete component list and links to where you can get them right down in the description. Some of the cool features of this build include strong rubber-coated magnetic mounts that let you easily snap the node onto your car or truck or remove it whenever you need to. It's also equipped with a large solar panel that keeps the node powered even when you're parked in somewhat shady areas. On top of that, it has active cooling, a small fan, that kicks on only if internal temperatures climb above 40 degrees Celsius or 104 degrees Fahrenheit. The vents are specially designed to allow great airflow while keeping water from getting inside. Best of all, the enclosure uses standard 18650 batteries, which are significantly safer than flat LiPo batteries, also known as spicy pillows. There are links in the description for the free STL files so you can 3D print the enclosure yourself with various versions tailored for different nodes. For this demonstration, I'm using the version designed for the Heltec T096. I really like this node because it's built around the NRF52840, which is incredibly battery friendly and way more efficient for solar setups than nodes running an ESP32. The T096 also features built-in GNSS for position tracking. You can easily disable this if you want to keep your location private, but it's an awesome feature for mobile setups. For instance, you can use your vehicle node as a base camp node, track each other during off-road group adventures, or just use your handheld device to find your car in a massive parking lot. All right, that's enough for the intro. Let's get building. Your first step is deciding which node you're going to use. I've designed enclosures versions for the Heltec V3, V4, and T096, and they should also work with similarly shaped modules like the FakeTech DIY nodes. There's also a version for the RAK1W, and even a plain version you can modify for whatever hardware you have on hand. Next, choose your antenna style. The files support both SMA and N connector options. After you download the STL files, I highly recommend printing the parts in ABS, ASA, or PETG. For this tutorial, I'm using black PETG glass fiber. Definitely stay away from standard PLA, as it simply won't survive the outdoor heat. You also want to avoid carbon fiber filaments. Carbon fiber is conductive and will block your RF frequencies, killing the Bluetooth and GNSS satellite signals your node needs to receive. Glass fiber, on the other hand, looks amazing, improves layer adhesion, and won't block your wireless signals at all. Keep in mind that a few parts, like the gasket, grommet, and sealing plugs, need to be printed using flexible TPU. When printing the main enclosure, I find that printing it on its side, with the cooling fan mounting facing down toward the print plate, gives the best results. Once your enclosure and cover are done printing, carefully clean off all the support material, nubs, and rough edges. To give the prints some extra protection, I always apply a couple of coats of UV clear spray to the outside. This helps seal the print, protects the plastic from degrading under harsh ultraviolet rays, and makes it look incredibly slick on your vehicle. Now let's start installing components into the enclosure. First up, we need to melt in the brass threaded inserts. You might want to slightly round out the printed holes first to make positioning them easier. We'll use a single M3 insert for the thermal switch support and 7M 2.5 inserts for the lid cover screw holes. If you don't have a specialized heat set insert tool like the one I'm using, a small soldering iron tip works perfectly. Just push them in until they sit flush or slightly below the plastic. We need these mating surfaces smooth, and even so, the TPU gasket can form a proper water-resistant seal later on. Let's pop in the cooling fan. Take a close look at its orientation. You want the air outlet on the side edge to line up directly with the vent slit in the enclosure, while the main fan inlet faces inward toward the internal cavity. I apply a little bit of adhesive to the side facing the enclosure wall. The glue I use throughout this project is T7000 black repair glue. It's a popular choice for smartphone repairs because it stays flexible, bonds beautifully with plastic, has a highly precise applicator tip, and can still be pried apart later if you ever need to replace a part. Pop the fan into place. It should fit snugly. If it does not go in, just double check that no leftover 3D print support material is clogging up the slot. Next, secure the thermal switch into its spot using an M3 screw. Since I'm using an SMA antenna for this specific tutorial, grab your SMA to IPEX pigtail adapter. Apply a generous amount of T7000 glue or silicone rubber adhesive around the flange base of the connector to ensure a fully waterproof seal. Make sure the mounting hole is completely clear of debris so the SMA connector seats perfectly flat. This ensures your antenna points straight up at a perfect 90-degree angle rather than leaning sideways. Slide the washers on first, follow up with the nut, and tighten it snugly. Be careful not to crank down too hard or you might crack the plastic, especially if you printed with ABS, which is more brittle and prone to splitting under stress. Next, let's mount the battery holder. The one I'm using comes pre-wired with a connector that matches the socket on our charge controller. To glue it down, I am using E6000 adhesive for this, which bonds incredibly well to these plastics. Position the holder so the wire leads point directly toward where the charge controller will sit later on. Now pay close attention to this next step, because checking polarity is absolutely critical in this project. The factory wiring layout on my battery holder's connector happens to be backwards for our specific charge controller, so we need to reverse it. We want the red wire to line up with the positive terminal on the controller and the black wire to line up with the negative terminal. You can use the edge of a small blade to gently lift the tiny plastic clips holding the metal terminal contacts in place. Use very light pressure so you don't snap the plastic. Pull the wires out, take note of which way the metal terminals are facing, and swap their positions before sliding them back in. Push them in until they click in place. Now our battery polarity matches the charge controller perfectly. Next, let's prep the power pigtail for the node itself. Take one of the jumper wires that came bundled with your node, strip the insulation off one end, and tin the bare wires. I recommend using solder paste for this. It acts as both flux and solder, making the job much faster and cleaner. Once tinned, insert the wire leads into the battery solder holes on the charge controller PCB, making sure red goes into positive and black goes into negative. It's always smart to double-check the polarity of this connector by comparing it directly to the node's power port before soldering. If it's reversed, swap the pins inside the plastic housing just like we did with the battery holder. We will now mount the charge controller module directly onto our printed cover. I'm using some 3M adhesive foam for this. I've used this stuff for years, and it actually sticks stronger over time. Cut a small piece of the foam and add a tiny dab of T7000 glue onto it just for that extra peace of mind. Position the charge controller module in a way so that the output connector will be close to the node's power input and stick it in place. For this project's solar setup, I'm using a Soshine branded 6-watt solar panel. This panel features two separate outputs, a regulated 5-volt USB port and a direct raw solar panel output. We want the direct raw output, so I simply snip off the USB cable, leaving a short stub that I will seal up later. When you buy the Soshine panel, it comes as a 2-panel set. The set comes with parallel connection jumper cable. We will repurpose this by cutting it right the middle, giving us two separate pigtail connectors. We only need one for this build, so save the other one for a future project. And run the cut end through the TPU grommet we printed. Just slide the TPU grommet onto the cut end of the jumper wire, and then feed the wire into the enclosure housing, then push the grommet in snugly. Now let's prep the solar connections inside the box so we can wire it to the charge controller. Carefully strip away about an inch of the outer protective jacket, making sure you don't accidentally nick the insulation on the inner wires. Strip and tin those individual ends. Next, grab one of the jumper cables that came with your charge controller to build a pigtail for the solar input line. Before you do any soldering, don't forget to slide a piece of heat shrink tubing over the solar panel cable, along with smaller pieces over each individual wires. Solder the corresponding wires together, making sure you get a good solder joint. Slide the tubing over your joints and use a heat gun or cigarette lighter to shrink them down safely. Like always, double check your polarities before moving on. Luckily, mine were fine this time. Give the node's power feed wires one final visual check to ensure the polarities match up correctly before plugging anything in. The Heltec T096 features two tiny IPEX connectors. One is meant for an optional external GNSS antenna, and the other is for the LoRa antenna connection. The text printed on the board indicating which is incredibly small, but you can find the correct LoRa antenna port sitting right next to the SX1262RF shielding. IPEX connectors can be notoriously frustrating to snap on. I find it helps to rest the node flat, line up the cable connector perfectly straight over the port, and use a small tool to press straight down. Just take your time and be careful not to damage the fragile connectors. Now, slide the node gently into its support holder. Take notice the small ramp-like structure built into one side of the holder. The IPEX cable should exit through that end. This ramp acts as a physical retainer that safely locks the IPEX connector in place so it can't pop off under handling or vibrations. Plug your power jumper into the battery input on the node, keeping a close eye on polarity. Next up is the cooling fan wiring. We need to wire our thermal switch sensor in series with one of the power lines running to the fan. I'm going to use the positive red wire for this. Route your wires through the enclosure to gauge the exact length you need, then snip the wires there. The connector that was already on the cooling fan wires won't match the sockets on our charge controller module, so we'll make another custom pigtail using one of the jumpers provided with the charge controller. Strip, tin, and slide some heat shrink tubing onto the red wire coming from the fan. Solder this red wire to one of the pins on the thermal switch. Then, solder the red lead from your new pigtail connector to the other thermal switch pin. Solder the two remaining black ground wires together, protecting the splice with heat shrink. Use your heat gun to shrink all the tubing down securely over your solder joints. Plug the fan connector into the second battery connector socket on your charge controller. Whatever you do, do not plug the fan into the solar panel input socket. The higher voltage coming directly from the solar panel will instantly fry your fan. Alternatively, if you want longer wire runs, you can always piggyback the fan wires and solder them directly into the same PCB holes used for the main node power output. Okay, now let's mount the solar panel onto our enclosure. First, temporarily attach the cover onto the enclosure. You can hold it in place with some masking tape or insert a couple of screws so it doesn't fall off while we are working on the panel. The rubber-coated magnetic mounts come with factory screws, but we aren't going to use those. The original hardware isn't stainless steel and will start rusting after just a few months outdoors. I've swapped all of mine out for high-quality stainless steel screws. My magnetic mounts use M5 screws, but some brands out there use M4, so double-check your sizes before buying replacement screws. Place flat washers and the plastic 3D printed bushings we printed onto each of the 4 screws. I highly recommend applying a drop of thread locker to the screws going into the magnetic mounts. Road vibrations are relentless and can easily back screws out over time. The very last thing you want is your solar panel flying off into traffic on the highway. Position the solar panel so that its output connector sits closer to the main enclosure. The rear magnets will require the use of 2 3D printed plastic spacers. With the solar panels secured, flip the node over so we can add the gasket. Remove the cover by flipping it back. Grab the TPU gasket we printed and fit it neatly around the rim of the enclosure. I like to use tiny dabs of T7000 adhesive in just a few spots. This isn't to glue it shut, but simply to keep the gasket perfectly seated so it doesn't slide around or bind up when you install or remove the cover. Next, grab the printed TPU sealing cap for the solar panel wire, add a little T7000 glue inside it, and press it firmly over the cut cable stub coming out of the panel to seal it permanently against the elements. Before we drop our batteries in, there is one golden rule you must follow. Never operate your node without an antenna attached, or you risk burning out the transmitter circuit. Go ahead and screw on the appropriate antenna. For this setup, I'm running a high-quality 17-centimeter whip antenna. To make things easier, position your solar node so the main enclosure hangs off the edge of your table or workbench. This next step requires extreme caution. We need to insert the batteries with the correct orientation. I've pre-marked the batteries with a red marker to clearly show the positive side. These batteries will operate in a parallel configuration, meaning both positive ends must face the exact same direction. Check the markings inside your battery holder to confirm which side is positive and carefully slide them in. Putting these batteries in wrong can easily cause a short, a fire, or personal injury, so take your time. As soon as the batteries snap in, you should see your node booting up. This specific unit is already flashed with the latest firmware. Use a small zip tie to organize and neaten up your internal wiring, then gently place the lid cover on and secure it. Be careful not to over-tighten the lid screws so you don't strip out the plastic or inserts. During the filming of this tutorial, I was actually short one solar panel jumper cable. In this B-roll shot from another assembly, you can see exactly how the finished product looks and how that cable properly attaches to the solar panel connection. Let's look at a few alternative options. Here, you can see the alternative method for connecting the fan wires directly to the charge controller by soldering them right alongside the node's power wires on the PCB board. This specific node was running outside under real-world testing, and you can see the active cooling fan doing its job nicely. Keep in mind that these black enclosures run a bit hotter in direct sunlight than the white ones I make, so definitely factor that in when choosing your filament color. To maximize your weatherproofing, you can apply a thin layer of silicone dielectric compound along the TPU gasket to help form an absolute moisture barrier. I also highly recommend using silicone dielectric compound on all your external antenna connections. This prevents oxidation, galvanic corrosion, and water ingress over time. And don't worry, it will not interfere with your RF signal or act as an insulating barrier between the metal contacts. If you would prefer to purchase one of these vehicle solar-powered nodes instead of building one from scratch, I do offer them already assembled, pre-flashed with firmware and ready to go. The links to all the parts needed are listed in the description. You will also find the links to where you can order completely assembled nodes if DIY is not your thing. Thanks for watching. I hope you enjoy building this project. My hope is to upload more related videos regarding Meshtastic and Meshcore devices and products in the future.